Today we're learning about two specific types of right triangles. We call these special right triangles, and you will use this year, next year, and the year after that. And the year after that, actually. So special right triangles, we have two different kinds. Our first one is what we call the 45-45-90 triangle. And for any right triangle, we know it's a right triangle because it has that 90-degree angle in it. For any right triangle that has degree measures of 45 and 45, then we know something to be true about the measurements of those sides. Now, if this is a right triangle, so that's the type of triangle that is based upon the angles. What type of triangle is it based upon the sides? Isosceles, good. So you'll notice because these angle measurements are equal, that these legs are actually congruent. So remember, in a right triangle, we have two legs. That's what makes up your right angle. And then the hypotenuse is the longest side, the side opposite of the right angle. So for every single 45-45-90 triangle, what we have that is the hypotenuse measurement is equal to just whatever the leg is times the square root of 2. So if you know your leg, you just multiply that by square root of 2, and that's your hypotenuse. So in general, we can say that the leg, if we call it the variable x, then our hypotenuse is x root 2. In the most simple and basic format, if this is a 45-45, the most simple and basic format, we would have 1 square root of 2, right? 1 times the square root of 2. So you need to remember this format. You need to remember that relationship because that'll allow you to solve for unknown sides. Okay? So 1 root 2, or just leg times root 2 is your hypotenuse. So go ahead and circle this equation here, put a star next to it, something to make it stand out to you, because that's the key piece for a 45-45-90 triangle. And we're going to use that information to help us solve for the unknown sides. Okay, so let's go and do a few of these. So this first example says find the missing sides. All right, so they gave us 3. Is 3 the leg or the hypotenuse? The leg. So what is A going to be? 3. Very good. What is B going to be? 3 times the square root of 2. Remember, your hypotenuse equals the leg times root 2. Okay, so let's try this one. If this leg is root 3, how much is A? Root 3. Exact same, it's an isosceles right triangle. What is C going to be? Square root of 3 times square root of 2, which is square root of 6. Good. Very good. All right. So now they've given us the hypotenuse is 5 root 2. So remember, your hypotenuse equals leg times root 2. So they've given me that my hypotenuse is 5 root 2. So my hypotenuse is 5 root 2. So then the leg root 2. What's my leg going to be? 5. If you want, you can go ahead and solve this equation. Divide by root 2, divide by root 2. Those reduce, and we get 5 as my leg. So this would be 5, and this would be 5. But I know that a lot of you are able to see this and recognize, well, if it's a leg times root 2, your leg is 5. That's the good. Now, the trickiest that this can become is this last example here. Here we have a 45-45-90 triangle, and they gave us the hypotenuse, but our hypotenuse is a nice whole number. You always like those whole numbers until now. Yes, Colin?
Square root of 6 in which will I will get 8 times the square root of 8 times and the square root of 4 times the root, which means
That works? But here's a much easier way. So this is my hypotenuse. So again, think back to your hypotenuse is leg root 2. My hypotenuse is 4. So now we just solve here for my leg. Divide by root 2, divide by root 2. But be careful, we cannot have that radical in that denominator. So our leg, what do I need to do to get rid of that radical? Good. Multiply by it on top of the bottom. So then I would get 4 root 2 over, what do I have in the denominator? 2. Oh, and what does that become? 2 root 2. So each of my legs are 2 root 2 and 2 root 2. When you do this, go ahead and double check to make sure you did it correctly. If I take my leg and multiply it by root 2, 2 root 2 times root 2, 2 root 2, or root 2 times root 2 is 2, 2 times 2 is 4. That would get you back to your hypotenuse. So you know that you've done it correctly. You have a built-in check there to know that you've done it correctly. Okay. So another way to think of this is that your hypotenuse equals leg root 2. You could also rewrite this as hypotenuse over leg. Hypotenuse. If I want to solve for the leg, I would divide by root 2 on both sides. As we do more and more of these, I'm sure some of you will recognize that and know that once you have your hypotenuse, you just divide by root 2. But when in doubt, go back to this equation every single time. Your hypotenuse is leg root 2. And again, if you want to use that variable x, that's fine. Or here, heck, we can just use the variable they gave us. If we're solving for side B is a leg, so B times root 2 equals your hypotenuse of 4, and then just divide by your root 2. Do exactly what we just did here, and you would get your B is 2 root 2. Okay, so either way, it's the same. Any questions on that? Okay. So now flip it over to the back side. This is our other special right triangle. This is what we call the 30, 60, 90 triangle. This is a right triangle that has angle measurements of 30 and 60. So in the 30, 60, 90 triangle, your short leg is opposite of the 30 degrees, and your long leg is opposite of the 60 degrees. How do I know that that's going to be the case? I don't know which one's the short and which one's the long. Go ahead. Right, so it's the idea that this is my small angle, so the side opposite of it is my small side. We could order the sides of my triangle based upon the angles. So for example here, your hypotenuse is always the largest one because it's always across from your 90 degrees. It's the largest in your right triangle. 30 degrees is the smallest of the three, so that's going to be your smallest side. And then 60 is the middle one, so that's your medium side. Now in terms of legs, since these are just my two legs here, so then the one opposite of 30 degrees is your short leg, because that's the smallest angle, and the one opposite your 60 degrees is your long leg, because that's the largest angle across from your leg. Okay? So it will hold that format every single time, that the short leg is across from your 30 degrees, and your long leg is across from the 60 degrees. All right, so the format for a 30, 60, 90 triangle is that so we usually start with our short leg. Our short leg times the square root of 3 is the long leg. Okay, so the long leg equals short times root of 3. Your hypotenuse is actually just double the short leg. So your hypotenuse is just 2 times the short. Or short times 2. So that's these two equations up here. So put a star, circle those, something to make that stand out. again, it's short leg. You double that for your hypotenuse, multiply it by root 3 for your long leg. Yes, Mom? Yeah, I think you would have encountered that because it's the altitude of it, right? Of an equilateral triangle would be, so that would create it into a 30, 60, 90 triangle, and then that's where you got it from. Yeah, very good, very good. All right, so again, bare basic bones here. If we want to start off with our short leg, call that x. Then your hypotenuse is just 2x, and your long leg is x root 3. So if you want to just write x instead of short, same thing. And I think it's really important to know the most basic form. So if this is my 60, because that's the long leg, 30, that's my short leg. So the most basic unit, if you wanted to think of it that way, my short leg is 1, my hypotenuse is twice that, and my long leg is 1 times root 3, so just root 3. So 1, 2 squared root of 3, or 1 squared root of 3, whichever way you want to think of it. So you've got to remember those formats. For 45, 45, 90, it's 1, 1, root 2. For 30, 60, 90, it's 1 for your short, root 3 for your long, and 2 for your hypotenuse. Okay. So let's go ahead and use this to help us solve for some of these unknown sides. All right, so here, what did they give us? What does 6 represent? The short side. That's nice. It's the nicest type of problem you can get. So let's start off with my hypotenuse. What is my hypotenuse? Look at your formula. Hypotenuse is just twice. Good. So 2 times 6, which is 12. Now my long leg is the weird one. What is that going to be? Okay, 6 squared root of 3. All right. With this, just a quick side note. If you forget the order, because I think the biggest issue here, to some students, if the hypotenuse and the long leg flip-flopped, you can always go back to Pythagorean theorem to see which one works. If you check this here, Pythagorean theorem, 1 squared plus square root of 3 squared must equal 2 squared, right? Because it's a right triangle. So I have 1 plus square root of 3 squared is 3, 2 squared is 4. That works. Whereas if you got it flip-flopped, if you messed it up and put it this way, 1 and 2 root 3, then when you would do this Pythagorean theorem, 1 squared plus 2 squared equals square root of 3 squared. This would be 1 plus 4, which does not equal 3. Okay? So if you forget, you can always go back to using Pythagorean theorem to help you remember which one's which. That's what I always use for everything. Alright, so let's go ahead and do this next one.
So this squared is larger than square root of 3 squared, therefore it must be larger than square root of 3. Therefore
Yep.
this is the opposite.
You've got it. Yeah, very good. So what Pauline was saying there is that 2 is bigger, so 2 squared is bigger than square root of 3 squared. It's the largest side. If you think of it too, just 2 is larger than square root of 3. So it must go with your longest side, which is your hypotenuse. So you can think of it that way as well. You think of it in ordering your sides based on angles. Very good. All right, let's take a look at this one here. What did they give us? The short leg. It's very kind. All right, so let's go and do hypotenuse. That's the easiest one. What's my hypotenuse? 2 root 3. Good, just twice that. Notice I cannot combine those together because one's not underneath the radical. All right, now the kind of weird one, what's my long leg going to be? Good, because it's root 3 times root 3. It's my short times root 3, which is just Very good. Questions on this? Okay. I want you to go ahead and try these last 20. See if you can get these kind of weird, tricky ones. Do you have any volunteers to come up for this one here? Would you mind doing all
Oh. Do I have to share the work or do I just do it?
Go ahead and just give the answers. Do we agree with this first one in red? Good. This is my long leg, and remember your long leg equals short times root 3. So if my long leg is 2 root 3, and I'm solving for my short, divide by root 3, divide by root 3, and you get short is just 2. And then you double that for your hypotenuse. Okay? And do we agree with our answers over here in green?
Yeah.
Good. So here they give us the hypotenuse. Here, getting the hypotenuse is actually pretty nice, because your short leg is just half of that. Your hypotenuse is 2 times your short. So if my hypotenuse is 10, then my short is going to be 5. Good? And then once you have your short, just times root 3. Very good. Questions on that? Okay, let's do one more. I want you just to draw it down here in the corner. So this one's 60. This one's 30. And let's go with... I'll call this C. I'll call this one D. Alright, I want you to try solving for the unknown sides here. Let's see what you get. This is a good one. Alright, let's see how you did with this. So what did they give me here? What does 15 represent? The long leg, the complicated one. Alright, so my long leg is just the short times root 3. So my long is short times root 3. That's my general equation I know to be true. So if my long leg is 15, my short leg is C times root 3. Okay, then solve for C by dividing by root 3. Divide by root 3. Makes except we can't have that radical in the denominator. So I need to multiply by root 3 on both sides. And so we end up with 15 root 3 over 3. Do we agree with that? Okay. Now can I reduce this? In what way? Good. The 15 and the 3 can reduce. Be careful, we can't reduce the radical 3 and the 3. Just the 15 and 3. The number is outside your radical. So these are both divisible by 3. That's 5 and 1. So we have then 5 root 3 is C. Do we agree with that? Good. So C is 5 root 3. And then once I have my short leg, the rest is so much easier. What's my long leg going to be? Double it. And what is double of 5 root 3? 10 root 3. Good. I just multiply this by 2. So D equals 5 root 3 times 2. And again, the radical protects what's underneath, so I can only multiply the 5 and 2 together, which is 10. Okay. Any questions on that? Awesome. Okay, so now what we're going to do is just some classwork practice with that, but I want you to work with someone next to you. So again, the rows will pair up. And let's see, who do we need to fill in? Tom, if you would just scoot over, and then you can work with Zane there. And then Lauren, you can either just turn and work with Zane or turn and work with Ethan and Nancy, whichever way you want to turn. All right, so let me grab the classwork for you. What's this? Oh, I forgot, you're the oddball. So just turn and work with Karen.
Oh, all right. Sounds good. What? All right.
Can you do the whole page?
No, please. Alright, so your classwork is this that I have up here on the board. So make sure you first recognize whether you're working with a 45, 45, 90 or if you're working with a 30, 60, 90. Okay, so go ahead and scoot your desks closer to each other so you can work with one another. And I want to hear you actually talking with one another about this and working together. The backside gets a little more tricky, but those are the good challenges. And then we'll come back together and go over it. Alright, so let's see how you did with these. Come on. Alright. So check your answers for A, B, C, and D. Let me scroll. Not sure what to fix it. Yes, Aaron. How did I get what? Okay, so this is a 45, 45, 90.
Oh.
So root 6 times root 2 is root 12, and then you have to simplify everything. Other questions on the ones you see right now? Let's try again. Okay, hold on. Okay, it's working. Okay, I promise I'm transformed. Hold on. Alright, here are the bottom ones. Check your answers for these. Do we have any questions on the bottom ones? Yes.
Two times the short leg.
Which one's your short leg though, right? Yep, yep, you got it. Other questions on these ones? Show me thumbs up, thumbs middle, thumbs down how you're feeling so far. Ava, what questions do you have? But do you understand where you go? You know how to fix it? And you do have a question? Okay, see if you can figure out a question. Okay, what's your question? Number one? Sure. Alright, number one, so it's a 45, 45, 90. So that means my side, the legs are going to be the same, and the hypotenuse is just the leg times 2. This one?
No. Oh my god.
Okay, so number one, this one's a 45, 45, 90. So legs are the same. Hypotenuse is the leg times root 2. They gave me my hypotenuse, they didn't give me the legs. So think back to your equation. Hypotenuse equals leg root 2. My hypotenuse is 18. I don't know the leg, it's just y. And then we know that it's times root 2. So I've just put in the numbers that we do that. Then you solve for y. Divide by root 2, divide by root 2. So y equals 18 over root 2. Cannot have that radical in the denominator, so multiply it on top and on bottom. So I get 18 times root 2 over root 2 is just 2. And these simplify to 9 root 2. And that's your answer. So always go back to your original starting equation. Same idea for like number, okay, 2. So number 2, this is my hypotenuse of a 30, 60, 90. Your hypotenuse equals your short leg times 2. And your long leg is your short leg times root 3. Okay. So if my hypotenuse is 14, how much is my short leg going to be? 7. So then my long leg is just the short times root 3, so just 7 times root 3. Does that make more sense to you? So always go back to those beginning equations when you're starting. Alright, other questions on the front side? Okay, let's take a look at the back side. Going to start checking your answers here. So here you gotta decide if it was a 45, 45, 90 or a 30, 60, 90 or none of them. Yes, Aaron. For the top ones? Number 8. Alright, so to check to see if it's a 45, 45, 90, I should have 2 of the same lengths. And the one that's times root 3, or root 2. For a 30, 60, 90, I should have 1, and then double that, and then that times root 3. So if I look here, do I have 2 that are the same? Nope. Okay, so it can't be 45, 45, 90. And now let's check 30, 60, 90. What's my smallest one?
31.
Good, 31. So that would be my short leg if it worked. Now my hypotenuse would be double that. What's double 31? Good. And then if I had my long leg, what would the long leg be? Good, 31 root 3. But we don't have that, we have 31 root 2, so it can't be a 36 minus that makes it. So you're just looking for that relationship. Yes, sir. Yeah. So 11, it says a professional baseball diamond is a square. The distance from base to base is 90 feet. So base 1, first base, second base, third base, home plate. So it's a square with 90 feet on either one. To the nearest foot, how far does the catcher standing at home plate throw the ball across the diagonal to square to second base? So home plate to second base is what you're trying to find. Well, that creates a triangle. And if my sides are the same, that's my isosceles, the legs are the same, which means it's going to be a 45, 45, 90. So if my sides are 90, then the diagonal, the hypotenuse, is just that times root 2, 90 root 2. So it doesn't actually require you to do any algebra there. Other questions on what we see so far? Okay. And let's see those bottom ones. Alright, so how you did on those bottom ones. So if you notice, you had to split these up into a series of rectangles here. Here, it actually just created 2 triangles there. Number 18 was a 45, 45, 90 mixed with the 45, 45, 90. Then the other one combined the 2 different ones. Do we have any questions on these ones? Yes, Jim. B in number 40? Oh wait, 20. Okay, so letter B in number 20. So right now we just have that it's that trapezoid. We want to go ahead and draw in that perpendicular line so that we have a nice rectangle with the triangle. Now because I've cut this down, the whole thing can't be 30. Well, this whole thing here is 30, so this B is not 30, but rather 30 minus whatever this chunk is. So using your 30, 60, 90 triangle, that's our short side, which is 5 root 3, so we just have to subtract that from it. But I can't combine those, so it just stays as 30 minus 5 root 3. Yes, Dave? Yes, so if you look at your assignment sheet, your homework is worksheet 2 in textbook. We have a quiz next class over these first 3 lessons. Also, if you want to double check your work with these last ones, the answer key to the classwork is above that. Any other questions on these last 4? Next class is when you're going to want to bring your graphing calculator or any scientific calculator that has sine, cosine, tangent. So bring your calculators next class. You won't use it on the quiz, you'll use it for the lesson afterwards.